Hello students, so in this lecture we will be discussing about some fabrication process of nanomaterials, nanostructures, and we will discuss in this lecture about direct writing. Now, direct writing is a process by which we can deposit or dispense any material over any substrate depending upon the conditions. Now, basically, there are three ways categorically you can say that are used in direct writing. The first one is the tip based or the probe based, and the other two are the flow and the droplet based. Now, we'll discuss about the first one here. Now, in tip based, the first one that is mostly used for lithography is the atomic force microscopy. Now, although this is a microscopic technique, which is actually based upon the difference, the potential that arises when the tip or the probe this approaches the sample surface. Now, the tip has also got an atom at its very end, and so does the surface, which is not uneven. So, whenever a tip is approaching, there has to be some sort of potential getting developed, and attraction and repulsion take place. It is exactly the same thing that takes place when two atoms come to form a bond. Now, this potential of two atoms coming together for bonding is represented by the Lennard-Jones potential, where it is actually a combination of an attractive and a repulsive potential, and the two forces balance each other, so the atoms remain at an equilibrium position, which is actually called the bond length, and in this case, probably the equilibrium position. The force experienced by the AFM as it scans through the sample surface, it gets reflected in current form, and we however see the picture of the topology of the surface. The tip diameter being 20 to 50 nanometers, which is sufficiently low to interact with an atom. Now, this AFM cantilever, so this is the structure, how the AFM works. So this is the sample, and we provide, there is a piezoelectric scanner to which the tip, this is where the tip is associated, tip, cantilever tip. So as it scans through the surface, it undergoes vibration based upon the topology, and those vibrations are again fed to a photodiode by means of a deflection taking place from the cantilever top surface. Now, this is the structure of wave. Now, when the suitable forces are exerted and external fields are applied, this probe is able to induce various physical and chemical process in the system, and which actually give rise to some localized nanostructures. So this is, so apart from imaging, this AFM is used for lithography as well, and is known as the AFM lithography. Now, the second way by which the direct writing can be done is by using an indentation method. Indentation are normally used to measure the hardness or other mechanical properties, but the mechanism can be used for lithographic technique, as the force applied on the tip can be modulated by adjusting the amplitude of the cantilever oscillations. Now, this is how the same similar to the AFM microscope tip. This also got a piezoelectric tip, and this tip again, as it moves through the sample, scans through the sample. This is the microscopic image of this tip. So as it just moves through the sample, the cantilever undergoes deflections, and deflections, by very well known Stoner's equation, is related to the following parameters, which includes the length, the beam length, and the thickness as well. Now, the structures, now this as a tip moves, so we can actually use this indentation tip to cause some elastic and plastic deformations into the material, and these deformations may in turn lead to formation of some nanostructures. Now, since it is a cantilever, there has to be a spring constant, which is again related to the thickness of the cantilever. And the oscillations are resonant oscillations are equivalent to the effective mass M equivalent and K equivalent mass of the material. So the deflection is causing some change in equivalent mass. Equivalent mass is when the two atoms come together. The equivalent mass that is subject to presence of these two atoms, this is the equivalent mass. So these are the two aspects of direct lithography. We will take up another aspect in our next classes.